Before we start this problem, there's a picture that I want you to see. This is the outside cube with an inscribed sphere and another cube inside the sphere. So it's a kind of nested objects inside each other. But I want you to get the overall view here. Let me show you. Here, what you have to see is this. Is that you can see this two lines going here. You see both are diameter of the sphere. This is a 3D figure, so I have to rotate it for you to get the feel. But you know, here this line looks short here, but it's not. Let me show you. See, that was a diagonal of the sphere, and this length is also diagonal of the sphere. Maybe I can show you this way. So here, this is what I'm telling you. These two lines are equal length because they're both diagonal of this diameter of the sphere. Now, here's what I want you to see. Yes, both are diameter of the sphere. And yet, this diameter is actually the width of this outside cube. Agree? You can see it, right? Now, what about the other diameter? Yes, it is a diameter, right, of the sphere, you can see. However, this is a diagonal of the cube from one point to the other. The farthest point, let me show you. It goes from this point to that point. But because the cube is inscribed in the sphere, that is also diameter of the sphere. So in other words, if you go from one tip of the opposite tip of this inside cube, that's the same length as going from top to bottom of the outside cube. The length or width, this is cube, so what difference does it make? If I put it this way, it becomes the height of the cube, right? So height of the cube, outside cube, is equal to this length from opposite corner to the opposite corner length of the inside cube. That insight is vital to solving this problem. So when you have the sphere inscribed in a cube and then cube inscribed in the sphere, the sphere becomes the conduit, that is the intermediary between these two cubes. There's something shared by these two cubes, that is the longest diagonal of the inside cube is equal to the side length of the outside cube. That's what I want you to see. Now, suppose this length of the inside cube was 1. Then how long is this diagonal? Well, you know, it's 1 and 1. It makes a right triangle. So this diagonal on the floor of the inside cube would be root 2. So the diagonal under is root 2. Height is 1. So therefore, this inside space diagonal would be root 3, right? If you see it this way, you can see forming a triangle. The base was root 2. This is 1, so therefore this is root 3. So this length is root 3. But then again, this is the diameter of the sphere, which is same as this diameter of the sphere, which is the same as this length of the outside cube. So if the inside cube was 1, outside cube is root 3.